Hello, Algebra Scholars. Welcome to Chapter 6 and Section 6.1 on rational expressions. A rational expression is defined to be a polynomial divided by another polynomial. So, for example, 4x squared plus 2x minus 1 divided by 3x plus 7, for example. A more simple example of a rational expression might be just 2x divided by 3. Remember, the word polynomial, even though poly means many, the numerator and denominator here, we would probably call them monomials, but they are still both polynomials by definition. So any polynomial divided by another polynomial, we call that a rational expression. Now, what I want you to pick up on here in the denominator, at least in this denominator, is that there's a variable. And depending upon what value that variable takes on, it's possible that the denominator would be equal to 0. And we know in math that anything divided by 0 is not good. We call it undefined. So, sometimes when we have rational expressions, we have things called restrictions. We're going to restrict the value of x. We might say x cannot equal something. In this previous example, it's a little tricky to see, but we would say x is not allowed to be negative 7/3. Because if it were negative 7/3, if we plug that in for x right here, we would see that we would end up with negative 7 plus 7. We would end up with 0 in the denominator, and that's bad. So oftentimes when we have a rational expression, we are asked to list the restrictions. Let's try an example on the next page. To start off, here are two really easy examples, ones that you'll be able to look at and answer without doing any work. So on this first example, we can see pretty clearly that x is not allowed to be 10. Just think of it this way. If x were 10, would you have division by 0? And if the answer is yes, then that number is what we would call a restriction. We're restricting x to not equal 10. See if you can figure this one out here. And remember, all we're looking at is the denominator. What can x not be for this one? What would make the denominator equal to 0 if x were equal to negative 2? So 2 times negative 2 is negative 4, and negative 4 plus 4 is 0. So these are called restrictions. Let's just pause this while I write out some harder examples. So here are some harder examples, ones we can't just look at and know what the restrictions are. So here's what we say to do. We're going to set the denominator equal to 0 and solve. And just as a reminder, we did this in section 5.6, although it's been a while since we've seen it. And whatever our solutions are become our restrictions in this case. So on the first example, we will set the denominator equal to 0 and solve it. And to do that, we need a factor sum chart. Two numbers that multiply to negative 6 add to negative 5. Negative 6 and 1. It factors into x minus 6, x plus 1. And we set each of those factors equal to 0. And we solve. So then we can say our restrictions for this problem are x cannot equal 6 and x cannot equal 1, because both of those numbers would make this polynomial equal to 0, which then means the denominator would be 0 and division by 0 is bad. In this next one, we'll set the denominator equal to 0. and solve, but look, we have a GCF that we need to take out first. Little factor sum chart here. The numbers are -3 and 1. Remember, we don't need to use grouping and rewrite the middle term because the leading coefficient is 1. And then so here we'll say x equals 0, x minus 3 equals 0, x plus 1 equals 0. So our solutions are 0, 3, and -1, and those solutions are also our restrictions. So x cannot equal 0, x cannot equal 3, and x cannot equal -1.